Perfect.
Yeah.
Well, dear colleagues, good morning, good afternoon, and good evening. First of all, I would like to thank Steve for inviting me to be a part of this session within Tony Naldrett Memorial Symposium. Tony, after our short conversation during EMA meeting in Beijing 30 years ago, informally suggested me to join a platinum community, and in fact directed me to a fascinating piece of research. And by doing so, to interact with international researchers, including many of you. Second, while choosing between various topics for today's presentation, I decided to draw your attention to some peculiar features of zircons from the Noril'sk-type intrusion, primarily because they shed a new perspective on their origin. And coming back to presentation, well, despite years of research into the world-class nickel, copper, PG sulfide deposits related to the Karelach, Talnach, and Norilsk-1 mafic ultramafic intrusions within the Norilsk province, their origin remains a subject of ongoing debate. As you know, a broad range of different or contradictory ideas for the formation of ore-bearing ultramafic intrusions in the Norilsk region has been proposed. Well, let's just mention a few: differentiation of a single magma, emplacement of multiple magmas with distinct compositions, volcanic feeder system, a crust-mantle interaction model, assimilation and metasomatic models. A common assumption in most of these models is that the Norilsk-type intrusions are coeval with the 250 million years old Siberian flood basalt, which erupted over a period of 1 or less million years, despite the available evidence for older uranium lead and younger uranium lead and rheniosmium ages. Well, recent detailed morphological in situ rare earth element and uranium lead isotope studies of zircon from the economic intrusions identify different zircon populations with multiple age clusters indicative of prolonged evolution of the magmas parental to economic intrusion in deep-seated chambers and later crystallization of the intrusive rocks in the crust. These and other insights on the origin of these deposits inferred from radiogenic and stable isotopes have been summarized recently in Elsevier monograph and can be downloaded from ResearchGate. Zircon, as a mineral, has a unique ability to preserve the isotopic geochemical signatures of early events: uranium, lead age, lithium, hafnium, and oxygen isotope systems, recording different stages of rock formation and magma sources. Until recently, no oxygen isotope data were available for zircon from the Norilsk-type intrusion. In this report, we present combined in situ hafnium and oxygen isotope data collected on the dated spots within single zircon grains from variously mineralized rocks of the economic intrusions. In addition, compositional features of zircon along with whole rock neodymium isotope data for the same suite of rock samples are briefly discussed. Well, these you already know, that these type of deposits occur in the northwestern corner of Siberian craton. They are associated with sill-like riftogenic intrusions, and I think that I decided to put this slide for you. This is this picture is a part of geoseismic profile section along profile Dixon Hillock. So here we are, this part of this section. And the analysis of the deep structure of the Norilsk area suggests a connection between the formation of these deposits in pillary structures and particular geological and geophysical parameters. Let's quickly mention them. They include high gradient downfalls in the basement. Here we are. A high abundance of host graben structures in the crust. A large volumes of intruded mass of mantle material between the crust and mantle, actually. Here it is. And the latter zone has been considered as a manifestation of ultramafic material injected in the subcrustal levels of the lithosphere and is further suggested to have been a voluminous source of primary magma for the Noril'sk-type intrusion. The thickness of this zone, as you may see, is about 5-10 kilometers, and its spatial extent of about 500 kilometers in this direction, okay, at depths of 32 to 43 kilometers. It is noteworthy that economic intrusions, and they locate somewhere here, are restricted to the region above this transition zone, which is considered as a typical feature of the basal part of the crust in oceanic and continental pillars. So this means that in general, the deep structure of the Norilsk area shows non-cratonic features with a differentiated crust of transitional type. And well, obviously, should be important criterion for regional tectonic forecasting. The intrusions have thickness up to here, this Noril'sk intrusion, and this is Talmach intrusion. So their thickness is not more than 360 meters, and they extend in the longest dimensions up to 20 kilometers. Location is clearly controlled by main tectonic structure of the Norilsk-type deep fault. Talmach intrusion was emplaced in the upper Paleozoic terrigenous rocks of Tunguska supergroup and carbonate rocks of Calargon formation. So this is here we are with Talmach. It locates both to the north, to the west and to the east from Norilsk-type fault, and Norilsk intrusion was in place stratigraphically lower than Talmach intrusion, and it's basically Devonian sediments, terrigenous and carbonate rocks as well. And what is important that massive sulfide ores up to 40 meters thick very frequently are not specially, well, they are separated by 2 thick meter of metasomatic rock, so they are not really lying at the bottom of these intrusions. And let's quickly have a look on the typical rock section of Talmach intrusion. So we start from contact gabbro, dolerite, then goes in taxitic textured rocks, including melanotractolites with patches of ultramafic rocks, then sulfide-bearing plagiaverolite with melanotractolite, and on the upper part there is a late sequence, so-called olivine-bearing and gabbro, and at the top, at the gabbro diorite with metasomatic rock again. So the bottom line of this slide is basically to show you that variations, bulk rock variations of zircon, uranium, thorium, hafnium, and leucetium is well correlated with the grains we were able to investigate and concentrate. Well, this is the main. Well, very similar picture. I will not bother you with all these drill cores, but it's just the same for Norilsk and for Norilsk. But probably more important that zircon has been observed in thin section as single or polyphasic grains, enclosed in kleiner pyroxene, in plagioclase, frequently intergrown with apatite. Rare examples show overgrowth of zircon on badellite, implying that badellite is likely to be the first mineral to crystallize in this assemblage. Separated zircon grains are commonly idiomorphic to subidiomorphic prismatic, transparent, as you could see, to semi-transparent, transparent light beige crystals that usually do not exceed 125 microns. The aspect ratio of zircon grains varies from 1 to 3, sometimes up to 6 to 7. Among the investigated grains, crystals that have a tetragonal prism, here we are, and tetragonal D pyramids are most abundant. So predominance of such type crystals, according to Pepin, is indicative of alkaline and high temperature condition of formation. Zircons are further characterized by fuzzy, smoky, I would say. Here you are, you can see no oscillatory zoning in catholuminescence and virtually total absence of zoning. Petrographic inspection, however, revealed a polyphase inner structure of the studied grains, which are composed of different up to 4 zircon populations with distant solid inclusion assemblages. Well, let's have a look quickly. Those which are in cores, inclusions are kleiner pyroxene, whereas rings, they frequently contain inclusions of silicate glass. Okay. Little bit geochemistry. As you see, all these economic intrusions have high concentration of thorium and uranium, with thorium-uranium ratio over 1, which is typical of igneous zircon. On the binary diagram, however, the investigated zircons clearly are distant from various geological settings, but they partly overlapped with glimmerite field and also with maritite rocks. Pronounced positive cerium anomaly, well, not so pronounced European negative anomaly is an indicative feature of these zircons. I really do not have much time to go in some details. However, you could see when we distinguish between these zircon populations, there is clear increase in all these elements, thorium, uranium, and rare earth from older zircons to younger zircons. Anyway, let's have a look quickly how they looks on these diagrams after Hoskin, and you could see that they generally match magmatic field of zircon. This is just an example how we investigate these small creatures, and we are trying to put first uranium lead, then should come oxygen isotopes, and afterwards hafnium and rare earth elements. And these are shown, well, it's an effort, I would say, but then what are the results out of that? So as you would see, the analyzed zircons show an appreciable variation in their hafnium isotope composition. Hafnium isotope values, when grouped on the basis of lithology, show significant difference. So this would be ultramafic part and toxic textured rocks. Then the most radiogenic hafnium compositions are inlaid siute rocks, gabbroic rocks, and the least radiogenic negative Epsom hafnium values can be found in the contactic rock gabbro-diorite, and also at Talnach in the lower part in Taxite. Well, the difference between zircons from different lithologies, for instance, gabbro-diorites, ultramafic and taxitic rocks, also gabbroic rocks, clearly seen from ytterbium hafnium and leucicium hafnium ratios. And well, little bit about neodymium. What we see that initial neodymium isotope composition of the upper and lower contact rocks differ from the other rocks, which have relatively restricted range in initial epsilon neodymium, about 1, I would say. The relatively uniform epsilon neodymium values could be regarded either as a characteristic feature of the mantle source or as the result of crustal contamination in a deep magma chamber. And let's quickly have a look on oxygen isotopes, because the notion with hafnium is supported by in situ oxygen isotope data collected for zircon grains from variously mineralized rocks of the Talnach intrusions. And very briefly, what amazed me a lot, most of these zircons plot in mantle field, so-called mantle field. Oops, sorry, I come back. And only taxitic zircons from taxitic textured rocks have the highest oxygen isotope composition. And this, our study is in a very good agreement with the bulk rock study which was done previously. Well, let's go to the conclusions. So zircons from the economic Noril'sk-type intrusions show mineralogical and isotope geochemical features that are not usually expected for mafic and ultramafic rocks. Predominance of type D crystals, according to Pepin, is indicative of alkaline and high temperature condition of formation, suggesting their magmatic origin. Well, basically, igneous origin of zircon can be seen from all other features, and hafnium isotope data on zircon, which reflect their source region, show a significant range in initial values along with less pronounced range in the initial neodymium values, which favors a model of mixing between the stenospheric and lithospheric sources. Well, it looks like I run out of time, so thank you for your attention.
Great. Thank you very much, Kreshimir. Another fascinating data set and